Okay. Okay, no problem. I'll return that. Okay, so let's start with what we discussed last time, that we will work on designing a Dropbox. Okay, so this is my, yeah. So, okay, so today, as we said, we'll be working on a Dropbox system design. Okay. Okay. So, what is a Dropbox? Anyone wants to talk about it, or what do you guys think about it?
It's a place to drop the files, folders,
And share, like basically
and
have a
share.
backup and share them. Yeah.
Perfect. Yeah. So it says like it's a file hosting service, something like that.
Yep.
Yeah.
Yeah.
So,
Document host. Yeah.
yeah. So and so what are the advantages, as you said, like it will be a sort of storage, isn't it? And it will be stored in a remote servers. So the headache of we storing it on our local drives, because our local drives going bad and all that stuff. So that will be already taken care of, right? If it's stored somewhere else, someone will take care of all the stuff. So we won't lose the data, and the data will be available at any place, anywhere. So the availability will be increased. Also, there will be it will be more reliable and also more durable, because we are paying for it. So someone will do all those things for us, right? And also it will be scalable, in the sense what they talk about scalability, in that it means like it will be an infinite storage, correct? So you can keep on dropping, but yeah, of course you'll have to pay for it. So if it's a local drive, we just store it on our hard drive, and then we have a limited capacity of hard drive, so we cannot grow. And that is why what they mean when it is scalable. And so
Yeah. So
Mhm.
we today we can also kind of do collaboration on documents in Dropbox. Are we taking up that feature at this point?
what is that? What do you
That
mean
was
by?
like Google Docs. So yeah.
Well, okay. So if I have not gone through the Google Docs as much, but I think, yeah, it is a similar service, right?
Actually, this is of different algorithm to collaborate all these things. So whatever discussing we are Tuesday we are discussing that thing, right? And data designing thing, right? I think some of the chapter will cover that part.
Yeah, and
Also
that's something
DDA we discussed on Tuesday, right? So you will find some of the chapter will cover that conflict, multiple people editing the file in parallel, how will we resolve the conflict, all that.
Or the conflict resolution, you mean to
Yes,
say?
yes. He want to look
Okay,
more.
so yeah, but here it's we discuss more about the Dropbox application as such. Okay, but there will be a lot of stuff to discuss internally, and as Shreyas mentioned, yeah, those things very specific to very internals of that we can discuss later, right? So conflict resolution itself is a big topic, and it might be a same different system design session in itself, right? Okay.
And so for now, just uploading, downloading files,
Absolutely.
and
It's
just
a
creating
normal.
that unique link to share, right? That's it.
Correct. Yeah, that's the only thing. So, and also we'll discuss some of it today and some of it on Monday. So let's see how much we can discuss today. I'll just keep it short for maybe 45 minutes or so. Okay. So as we said, now let's go with the requirements what we will have for our Dropbox. So the functional requirements. Okay, so what we will be looking at here is the user should be able to upload. Okay, sorry, upload and download a file, right? So files and whatever photos and everything, correct? So that will be one requirement. Second will be user should be able to share these files, correct, with other users. And the third will be our service should support automatic synchronizations. Okay, so automatic synchronization, what I mean is like if a user has different accounts on different devices, sorry, same account on different devices. So whenever he uploads something on one device, so the same thing or the same file or the same modification in file folder should be reflected in the other device. Okay, so that is what the automatic synchronization will be. And here the upload can be for large files. Yeah, someone has something to say. Upload large files, it's say in some like GBs, okay, in this case. And also it should maintain the ACID properties. Okay, so the ACID, it should guarantee that. So our service should actually take care of it.
So why ACID in this scenario?
Because,
We are anyways just uploading, right?
yeah, we are uploading, but for reliability we need that thing, right? So it should be there should be consistency and everything. So even if there are concurrent users, like we discussed about conflict resolution and all that stuff, so those things should be taken care of. And that is what is actually one of the requirement as per the grokking also.
Oh, okay.
And second is we should be able to do offline editing. Okay, and there is one more thing what they talk about is having a snapshot. Okay, the system should support snapshot. And what snapshot means is like when we take a snapshot, so that becomes a version. So we can go to any version of any files using a snapshot. But I think that we won't cover here. We'll just keep it as a P2 requirement. Okay, and then now if we come to our non-functional requirement. So anyone can guess what the non-functional requirements will be?
Definitely consistency, because we are syncing and want to see the same changes across different devices.
But should it be a strong consistency or?
No, eventual consistency will work in favor of high availability.
Yeah, at least availability should be high, right? That is one thing for sure.
Durability, data must not be lost.
Yeah, reliability and durability is also important. Correct. So you said reliability, right? Reliability.
Lots of files will be uploaded, so scalable.
Okay, yeah. Just give me a minute. I'm just correcting all. Okay. And what did you say? Scalability, right? So if you have to handle a lot of files.
And low latency.
And that should be in high availability, right?
No, high availability means it's always available. There is no downtime of the system. Low latency means when you are uploading a file, it should be uploaded as fast as possible.
I don't know if latency is important for this. Like in OneDrive, we just want to make sure our file is available and it is safe.
And I think latency would depend upon the size of the file you are uploading, right?
Exactly. If you are uploading 2 GBs of file, you cannot sit for the whole day.
No,
So
no,
that's
don't
why they
say,
have
but
this
then
concept of chunking the file in small parts and uploading it in that.
Oh, okay. You're saying about that, right? Okay. So if we just divide the file in small chunks, okay, that can improve our uploading and all that stuff. So will that count under low latency? Okay, no problem. So we can
kind of saving the bandwidth. I mean, maybe low latency is not the right word for it.
But throughput is what I say, like, I would think, right? The server should be able to take more.
Throughput is the right word.
Okay. Network. So we are saving on the network bandwidth, correct?
And the cloud storage size, yes.
Yeah. So all things related with that. Okay. Storage.
But if we are talking about low latency, what latency exactly is good for us? 1 second, 100 milliseconds. If we are talking about low latency, how to measure it?
Yeah, so that will be very challenging, right?
Yeah, it's not clear.
Yeah, so therefore I think we just put it throughput, but it is almost coming to that the system should be very responsive and all that stuff, right? So if we
Yeah.
divide that file in different chunks, so that would be much better. Okay, that is a good one.
Yeah.
And what else? Also, they talk about like fast sync speed. That is more important, they said, because if you are actually updating a file on a particular device, so the same for the same user, if he opens other device, that should be updated very quickly if he's online, of course. So that is one requirement, a non-functional requirement. Okay.
Yeah, and it's not clear, and you didn't mention it about ACID guarantee and offline editing. What do we exactly want to guarantee if we want to edit it online? Yeah, you and me are editing on offline. What there will be conflict, yeah, and it should be resolved manually. I don't think that we can guarantee consistency as example. I don't know.
Okay, so see, for offline, what we are saying is that if a user wants to modify some file, if he does it offline, so when he comes back online, he will sync with the remote server first and understand what is the status of that file. Based on that, he will actually take a decision. The service will actually take a decision based on what the current version of the file is in my local client and the remote. So based on that decision, it will actually update the file. And also in some cases, we'll have to do if the conflict is very different, then we'll have to do a manual conflict resolution. Okay, so I'm also not very clear on that, but yeah, surely you can add for
Santosh,
that.
Santosh, I think that offline editing would be part of Dropbox paper, not Dropbox as a storage service, right? Like, I think there's some sort of conflict in that. Like,
Yeah,
Dropbox
that's the client Dropbox.
Sorry.
The client of Dropbox can edit on his own machine, right?
Yeah, but the access storage, like the Dropbox is concerned with storage of that file, not offline.
No, we are designing the whole Dropbox. Basically makes a folder in your local machine, which you can use like a normal folder.
Yeah, and you can sync. So if you add something, it
Yes.
syncs to the actual cloud.
Yeah. So
Okay,
the way I look at it
One
is
question: is the sync a real-time sync, or how is it like? When I say real-time sync, when you are typing a document.
When you're online, it will be real time.
Rory will call when he gets an ID. In the meantime, I'm going to go.
Can you actually mute someone? Okay. So what we are talking about is like we, as everyone says, it will be a workspace. We'll actually define a workspace folder in our device, and typically a user will have a couple of devices, and they will have different work service for each and every device. Whatever we update on a workspace on any device, that actually has to be synced on the other devices, right? And also the conflict resolution in this case will be the same user actually working on the same file in his workspace. Okay, he is very has the whole control of that file what he is working on, correct? So he knows how to.
My question is, let's not talk about multiple devices. One device, but within a workspace, if a person is opening a document in that workspace and keep on changing the document, the sync happens in the real time, like whenever he is changing, the sync is happening immediately, or is it like in a scheduled way, like every 5 minutes it will keep on syncing?
Every time you save the file, if it's an auto save, it would every edit it would save.
Yes.
Every time you save, it will just update.
Because there is no concept of commit here, right? So every save is kind of a version of the file.
Yeah, every save is like a git commit.
Yeah.
Exactly.
So because anytime whatever is doing in a workspace, it is monitored by different events. Okay, and based on the events, actually, if it is online, it will also communicate those events to the remote server. Right. So it is almost as good as it's actually uploading continuously. But it again depends on the bandwidth and all that stuff. But it will do it more smartly because its client is also more intelligent.
Basically, you're saying when a document is opened, he typed and saved, and then he did some changes, modifications again, and he saved. Each save is a different version for Dropbox.
Yeah, it will be almost like a different event, right? It has to be, no?
Okay.
So even if you write something and
So
if you
excuse
delete
me, is it? Hello, I'm sorry to interrupt.
Sure.
Yeah, so is it just like a OneDrive save where we save it and then it saves both in local and in OneDrive as well?
Yes, if you have the
Almost like
desktop
that,
app
yeah.
of OneDrive.
Yeah.
Because normally between the saves, there won't be much time, especially in terms of document editing, right? That's why I'm asking, like, whether it will be like in a scheduled way, like every 5 minutes or 10 minutes, it will keep on syncing and then do that.
Because see, whenever he is doing something, that it'll generate an event, and that event will also be stored in its local metadata. Okay, as well as it will be communicated to the remote server, and so they will have a async way to communicate that, right? So it will lie in a queue. So first
what I'm saying is, by the time we edit, save, and then again re-edit and save, the file which was supposed to be uploaded is already changed again. So how does it upload? That's the question.
Yeah, so because the previous one, if you have actually first time you actually created a file, so that message will already be in the queue. It might be going, right? And so again, you do some changes in it, so there will be another event generated for that and another message sent to it. And if
but
it
your local file system is not a I mean, time series kind of a file system, right? It won't
No,
keep.
but then locally, the Dropbox client, like it does have a local database, a very lightweight, something like SQLite. So it has all the history of what all edits, versioning you did.
Yeah, the client is a smart client here, and it has a heavy. It's not just a browser client, yeah. So you'll have to have different versions for that.
Okay, it's not exactly a file system. It's a
no,
it's a
it is
Dropbox
not.
file system.
Yeah,
Okay.
yes. So it's slightly different, yeah.
Yeah, it's backed by a database which can store versions. Okay, got it.
Yeah.
Also, later we can discuss whether we are doing a pull or a push for keeping and sync.
Sure. Yeah. Whenever you guys want to add, you can surely add. Absolutely. Okay. So now what they were talking about, some of the design considerations are like, so the read-write volumes will be huge. Okay. And also the read-write ratio will be almost the same. Okay. Because whatever you write, you might read it, and there is no concept like someone uploading a file and million people watching it, right? There might be some where we share it, but not the huge ones like the celebrity ways what we did discuss last time. So therefore, read and write ratios are going to be the same, and then as we discussed, files are going to be broken down into small chunks. Okay, so the reason is it will be for better network bandwidth as well as for the storage and all those stuff. And we will also keep the local copy of the metadata and all that stuff. So we'll come to that later when we actually look for the plans.
Question here, Santosh. So if we have the same number of reads and writes, do we call the system write heavy or not?
If you have reads and writes, so it is both will be the same. No, you will also.
Yeah, we can just say it's data
but still
intensive.
it will be write heavy because when once you upload that file, you still need to sync it to all the clients, correct?
Yeah, that's what I felt like. If they're same,
yeah.
write has more processing power, more things to be done in the back end. So
but look at the
depends
way,
on our architecture, no? We may be just either pushing from server to all, or maybe all the clients are fetching once in a while the latest. Has there any been update?
It will always be a push until and unless a particular client is offline.
Right. So whenever if the guy is offline and he does editing and then he actually comes online, so he will also again push, right? But then when he pushes for the other devices, they will have to read the modified versions of it. Correct.
The server won't push to them. They will fetch it when
server
the device
might
is
also
online.
push. Server also might push, but it depends again how actually the model will be, right?
Yeah.
Okay. So now just looking for a very high level estimation. I know that it might be required or not. It will be a debatable thing, but I'll just go with the very high level ones. What they talk about is Dropbox has 500 million users, signed users or registered users. I think there are more now. like 700 what I just read. And then they have a daily active users around 100, okay, maybe more also. And each user on an average has, it connects via 3 different devices, okay, na average. Three devices. So one will be a desktop, one will be a mobile phone, and the other will be browser. That is what I assume. But if something I'm missing, you can surely add. And now if we consider each file average file size to be something like 200 KB. So we are looking for the complete 500 million users to be around something like 10 PB data or total. So this much will be the petabyte data. And other thing is if we, so this will be for, and also they talk about the QPS in the sense, for QPS what the calculations will be like if you have 100 million users and if they do some 2 uploads or 2 modifications per day, okay, and then if I divide all these things by that number, which is like 86,400 something seconds, right, that will come to around 2400 QPS. Okay, so this will be that much queries per second. I think the server should be able to handle it, right? And now if we look for the high level design, sorry, go ahead. Okay, you want to say something?
No.
Okay, so is it Shashank? Okay.
No.
Oh, I was able to hear you well, so I thought you're back again. Okay. So now, as we discussed earlier, in a high-level design, what the Dropbox application is, whenever you install that Dropbox application, it is actually tied with a folder called workspace, or we define a workspace folder. And that workspace folder, whatever the files and folders, whatever you upload in that workspace folder, they will be uploaded to our cloud storage. Okay, and that is the way it will work. And whenever it is uploaded to cloud storage, and if we have a workspace, because workspace folder will be for each and every device, so the other devices also will pick up or get synced from whatever workspace folder a user updates on one of the device. Okay, so that is one way. And the second is, now there will be 2 ways the files are stored. One is the actual file will be broken down into small chunks and it will be stored. So it will be blocks of some size, like maybe they described about 4 MB, and that is a reasonable amount of size. So you can actually upload that. But also the files will have a metadata storage, and that actually corresponds to a file name, file path, and file creation date, and all those stuff. So that metadata storage is not going to be stored in a cloud storage, because when we talk about cloud storage, it is mostly something like an S3 or so. And I think Dropbox was using S3 for a long time, but now they have their own data centers where they also do the object storage in house. That is what I heard. But if in geographies, if it's not possible, then they still use S3. So it's a hybrid model for them. And the metadata storage actually will store everything about the files as well as the chunks, and as it might also store about the folders and all that stuff. And then there will be another service which will be like a sync service. So if you look at the high level, it is about the 3 components in this case. One is the service which will actually upload the chunks, which they call it as a block server. Okay, so now I'll just quickly draw this stuff here. Okay. So this will be my clients here. Okay. And then if I have a service or a server which will actually upload, and then I call them as a block, it is called as a block server. So this server actually will interact with the client, and then sorry, I'm not used to this drawing, but yeah, fine. And so it will actually interact with the client, and then this client will the block server, if there are any modifications or if we put any file in the workspace, that will be uploaded to our cloud storage. Okay, I don't see any cloud storage here. Okay, I'll just use it. So this will be the cloud storage. So it might be something like an S3 or so. So that we will upload here. I'm sorry. Yeah, go ahead. Okay,
No,
so
sir.
and then we'll have another one block, which will be the metadata storage, or a metadata server. And so this metadata server will actually metadata server. So it will store all the should have drawn this earlier. Okay, so the way it represents is something like this. You come from here. Okay, so you'll have something like this. And the clients will actually interact with the metadata server, but they won't directly interact. Actually, it will be through the synchronization service. Okay, and then this, whatever the data which will be stored, it will be either stored in a SQL or NoSQL based on the way we require. But if you look at the SQL, why we call it SQL, because it guarantees the ACID properties. And secondly, the only problem if you use SQL or but then we won't be able to scale well. So if we use NoSQL, we can still use it, but all the ACID properties, everything has to be done in the application logic. That is what they say. And I think Dropbox uses MySQL. That is what I've read somewhere. And but they have modified the MySQL in such a way that they can scale it. Okay. So this is one thing. Yeah, go ahead.
Yeah, Santosh, actually, I just want to understand that block server part. Because when we are storing any file on S3, so S3 also do a like uploading part do in a multi-part purpose. Like it doesn't upload the whole part. It does a multi-part uploading. So what does mean that block server here?
Actually, I think, need to access these blocks when comparing with the client. That's why we are manually making our blocks.
Sorry, what was the question?
So why is block server used when S3 and all will actually divide it into blocks for storage?
There is a lot of disturbance. Can someone mute, please?
Yes, Santosh, you can unmute yourself, I think. No.
Yeah, so I was asking that when we are storing data on S3, so S3 itself do the uploading part in multi-part purpose. It doesn't upload the whole file in one go. So here we are seeing that block server. So what does the purpose of this block server like? We are itself making a chunk of all of the files and then we are uploading. Is it like so?
We are making the chunk in the client side. I think that's why.
Right. So we make chunks in the client, and then this block server or the service actually interacts with the client, and then it takes all the blocks and then it just pushes onto this cloud storage. Okay, so that is what is there. So the cloud storage can be S3 or maybe their own object storage.
Okay,
I think what
so
Deepika is asking is that the cloud storage S3 automatically does the chunking. So why do we need to do it at the client side?
We want to access chunks on client side. That's why.
no,
Yeah.
but
Also, Also to
what does a chunk mean? Because like let's suppose we are writing on a file. So like what does it mean of chunking of that file? Like
so
we will
chunking.
when we,
Yeah,
Mhm.
chunking would mean that you are dividing the complete file in parts, and you will store the offset of each chunk and the size of each chunk. And the other benefit of having chunks in the file is that you can upload the file in parallel. Like all the chunks you can upload in parallel by separate threads, right? So
Right.
upload can be faster. And
Yeah.
similarly, you can download the file in chunks, so that will make the download also faster. And whenever there is an incremental update in the file, you don't need to upload the entire file again in the cloud. You can just upload a particular chunk where that change happened, right? So it will save some bandwidth also.
Perfect. Yeah. So if we do all this chunking on the client side, as she mentioned, so we have a lot of advantages, right? So we have the control on the chunks, and we can only upload those chunks which are modified. So therefore, chunking on the client side is better, and that is what they are doing it. Okay. So if S3 handles that, if you actually push a bigger file on the S3, it might be storing it in chunks internally. So that might be different. But for us, we are only worried of the chunks what we create and the chunks what we are uploading. So how S3 stores are inside, that is what S3 will maybe the internal implementation of S3. So, but we are not taking, means at least the Dropbox is not taking anything that advantage of those things.
So I think we just need to know that how the S3 stores the metadata about the chunks, like how it stores the information that what all chunks belong to one file. So for that, it uses one metadata file where it stores the mapping of chunks against a file, particular file, right? So that's all we need to know.
Yeah, but see, if for us, like when we push in any chunk to that S3, so we just need that path, because what I think, this block server, when it pushes for the first time, actually whatever the path it gets when he pushes one chunk, that actually is updated in this metadata DB. Okay, so for us, even if the S3 might be maintaining the other chunks and all those relationship, but for us, we need to know only the chunks path, and that all that information will be stored in the metadata database. Okay, so this will be the metadata.
So as per my reading on Dropbox, meta servers are in their own infrastructure, basically their own data centers, and block servers are in AWS EC2, because they want to make block servers near to the S3 and meta servers near to the metadata which they are their DB.
Okay.
So both are different spaces. So so whenever a block server goes and stores something into the cloud, it knows what it has stored. It has to save it into the meta store. Since it is in EC2, which is in different location, it cannot, when it makes a DB write, it would be a costly network operation. So what they are doing is, instead of block server writing directly to the metadata DB, they will contact this meta server and do this metadata update, basically.
Okay, so you're saying
block server will call the meta server.
This is the way the flow will be, instead of directly writing it here.
Because of nearness to the DB, meta server will take care of writes. So block server will never talk to MetaDB directly.
Okay, no problem. No, but because that is what the Groking was saying. But if you are sure on that front, so no problem. So I can just remove this.
I have gone through that actual video of Dropbox evolution in YouTube.
Oh, that MIT version, right? Okay.
Yeah.
So the block server actually interacts with the metadata server in that case.
Right. Actually, with the load balancer, I mean, because there will be multiple meta servers.
Right. So it's not directly writing the metadata. Yeah, that also makes sense, right? Because you will have a control on it, and then when you are actually metadata server, there will be a synchronization service actually will take care of all that stuff. Yeah, sorry, someone was talking about it. Go ahead.
I had a question on the upload part, right? So, is it like a block server acts as a kind of a proxy between cloud storage and client, or client directly uploads onto cloud storage? So the HTTP connection or whatever upload HTTP connection, right? Is the connection is directly between client and cloud storage, or because if you are going through block service, right, it's just an additional hop. It may add burden on the block server part, right? So it's basically what it's doing is it's just streaming the data onto cloud storage. So I was thinking like, will block server redirect client or some kind of URL it generates and give it back to client so that client uploads it to that location?
I think
But
the
still,
block server
I guess the
service should
hop
do
is
that, right?
needed. Still, the hop
Sorry?
is needed because of retries or any consistencies and all. I think hop is still needed. Client cannot.
No, but we are talking about the file here, not the actual metadata. So
Yeah,
suppose if you're
actual blocks
uploading
only.
yeah.
Then we are putting burden on the client, where client maintains those information which are uploaded, which are not uploaded.
No, but typically you will have a client library, right? Like you need a agent sitting on the client side also. Like when you install Google Drive, for example, you will be installing an agent which sits on the client side, which actually talks to the metadata server or whatever block server. But the question that I had was, will the communication from the client with respect to uploading, is it directly with the cloud storage or with the block server?
No, it's not. It's not a direct connection to S3. It is a hop with the block server only.
I think that's the question. Why do we need the block server?
Yeah, but see, if multiple devices and then clients are uploading, if one client is making an upload and another client is also making an upload, I mean, with a different device, client has to take care of storing that DB, what meta store has been stored and other stuff, right? Now it is part of the block server. Block server would also have some responsibilities.
Yeah. So it is
same
talking
file is
about
updated by two clients, then who does the conflict resolution if we do not have the block service?
Right. So for our application, we need it, right? At least for the Dropbox application. That is what I think. Yeah, maybe it's.
And one other thing, what they are saying is, if a particular block is already been there, let's say if two people are having the same video in their workspace, and it's essentially the same file, right? So they don't store it two times for the two different clients, two different users, because it's essentially same set of blocks.
So it's a
identify
deduplication.
that blocks.
That's a deduplication, right? Yeah.
I think that's not only on files, but just the binary chunk. If the same binary chunk for a video is
right. It is
overlapping
not
with
a
the binary
full
chunk.
Yeah,
file.
it's a binary chunk.
Right.
So maybe that kind of things can only be done with block server, right?
No, I'm not questioning the need of block server. So block server is required maybe just to query the like the location of this file, and which is like metadata, I would say, but not the actual file. I'm thinking like client can directly talk to cloud storage. I'm just trying to understand the need of block server.
So you are saying that
file.
So if it's only a file, it first connects to the app server, and then it is given a path directly to upload to the cloud, right? Yeah, I think that might be also.
So that would reduce some kind of additional hop that we are doing, right? So otherwise we have to go through this block server, even
then
for the
agent
file.
But your agent has to maintain state in that. So and in your agent,
but
it needs to, right? Anyway,
anyway
it needs to.
Yeah, but see,
it needs to know like how much he has already uploaded.
So if it's a big file, like a 5 GB or file, so it can do that. But then when it is divided that file into small chunks and we just modify a small portion of it, then it doesn't need to go, because it still has to go to the block server to find out where that file is and everything, right? So whenever it's updating, but for the main dump, when it is dumping it, so at that time actually it makes more sense to go directly. Yeah. But I don't know about that. Yeah, sure.
No, but then
but it can also be an abstraction, I would say. Tomorrow, if Dropbox wants a different storage system, not S3, then it can be different, and like every time client cannot.
Yeah, but then they will, yeah, client won't be, but okay. So you are saying in that case, the path what they are going to point in the client, so that those modifications will have to be done. But the client is going to still refer to the synchronized service to all those, to do all those stuff, correct?
But then
so even if you see,
like it will also expose their this namespace and things to the client, correct?
Oh yes, definitely.
Which they might not want. It's not about might, like they will never ever want that.
Correct.
What was that come again? I didn't get catch that.
They'll expose the port on cloud to the client.
Expose everything, like how your structure is, what are your URLs on the cloud, and then anyone can play around with them, correct?
Deduplication logic, business logic.
That they don't
because
want.
Now all those URLs will reside on the SQLite DB which is present in the client application, correct?
Yeah, even though the storage is in S3, I think authentication and authorization is still with Dropbox only, I guess.
Yeah,
so
I think S3 is just just considered as a file to write binary on top of. We don't have to make assumptions about what S3 can provide.
So because of that authentication and everything, we still need our own, the Dropbox needs its own block server. Yeah. So what they talk about the client here in this case is like the essential operations of client will be upload, download file, detect file changes, and handle conflicts when it is offline on concurrent updates and all that stuff. And then so how the actually the client is has these many components like 1, 2, 3, 4. One is it will have its own internal metadatabase. Okay, the way what we have it here. So that is like a local database. Second, it will have a component called chunker. This chunker actually will convert the file, break the file into small pieces. And also the chunker will be responsible for reconstructing the file based on the chunks what it receives. Because when it wants to read, when it wants to download, so it will take chunks which are coming to it, and then it will again form the original file and give it to the user to read it. So that is what the chunk service will do. So the modifications by the user will be transferred to the chunk, the cloud storage via this this chunker. So why it does that? Because we discussed, because of the bandwidth and synchronizations time, everything will be much better. And then this watcher, whatever this component will be, this watcher will actually keep watching whatever that workspace folder is. And whenever a user tries to create, deletes, and all those stuff and on any of the files and folders, so those events will be generated, and those events will be actually will be monitored by this watcher. And then this watcher will in turn give all these events to the indexer. So this indexer actually, so this is the fourth component, which will actually interact with the outside world. So like from the client, it will actually interact with the synchronization service. And and then it will actually compare when it goes offline. First it is offline and then it comes online. So it will directly connect with the metadata, remote metadata server, and just try to compare what are the differences about the file. And then they will actually take a decision of how to upload or download the file and all those versions. Right.
So watcher is watching a particular file or change or a workspace, I guess, right?
It will watch the whole workspace.
And indexer is what? What does it do?
It will process the events received from the watcher and update the internal metadata first with that information. And whatever the chunks are when they are successfully uploaded to the cloud storage, so then it will receive everything from the remote metadata base, because some other client might have some client of the same client of other device might have modified that file. So that will be stored in the remote metadata base server. So that will also come to the indexer first, and then it will look at the internal metadata base whether it has to upload. Okay, and based on that it will upload, and then it will sync with the current workspace of that particular device. So the indexer actually communicates with the remote database, metadatabase, and also it keeps the local database in sync with the changes. So these are the 4 components. Yeah, go ahead.
I think in client side, they have to maintain something like a Merkle tree, right? Merkle tree is to basically, like, if you have a
figure out which chunk has changed.
Yeah, which chunk has changed immediately to find it in linear time, and only that chunk will be uploaded, right?
Yeah, but that you can actually use with some hashing algorithm also, right?
Yeah, why do we need Merkle tree here?
Merkle tree is hashing only, right?
Like, but you take hash of all adjacent lines of code, and then you take hash of all the hashes, and then you can identify the line just by looking through the tree, which hashes have changed.
Yeah, but this case is it's more simple that I mean, Dropbox, we just need detect if file has been changed somewhere else. Yeah.
Merkle has dependency.
The file has changed, but within the file, which block has been changed? That has to be uploaded, right? Not every time you upload the whole file itself, right?
Yeah, but why cannot we just compare by list? Okay, in case of Dropbox, each chunk is 4 megabytes. Yeah, 4 megabytes.
Right.
I'm not sure that we need Merkle tree. What is our file maximum size? Maybe 1 gigabyte. Yeah, I don't know.
Yeah, so 5 gigabytes maximum. I think they
irrespective of the size of the file, the block size is constant, right?
Yeah,
so with the block sizes, Merkle trees can be formed.
Right, but Merkle tree will make it log in to find out which block has changed instead of searching every single block.
No, see, when you are actually changing, you are modifying a block, the client will modify the block, right? So the client already knows what block is being modified.
The client will modify the file, right? Like, I change the word in the Word doc. I don't know in the binary which particular offset it is.
Yeah, so see, when the client is actually user is actually modifying a particular file, so this watcher is actually completely watching the blocks also, right? So it will get an event on which block this change is happening. So it will surely know
which. It will get an event on which file has changed, not a block, because watcher cannot do that, I guess.
Okay, so
it can only know which file has changed.
Absolutely. So if
then it will know. Then it has to find out from Merkle tree or some kind of a data structure similar to that, where which block has changed, and only that block has to be uploaded, I guess. Otherwise, uploading the whole file every time, I guess it will be a
no, it's not going to upload a whole file for sure. But see, when you are actually updating a particular file, okay, so when you actually go down in your API system API also, so you exactly know on what storage, if you go to the storage driver, you exactly know on what block you are working on, correct? So there you can surely get an event. So what block actually is getting updated. So those
talking about disk, right? Within a disk, you're saying.
So that is what, no, because the client is always going to use the client operating systems, right? Whatever it might be, Linux or maybe Unix or maybe even Windows and all that. So it is going to take the APIs from there, and it's going to find what the storage driver, which block actually it is referring to. So that can be easily get. It doesn't have to, if Merkle tree is being used, but I think it will be a heavy usage here, right? So it is like a client is just because we already have all the information.
McClary is not heavy, I guess.
It is just instead of O of n, it is 2n. You just store the tree above it.
No problem, but I don't see of the mention in grokking also about that, but yeah, sure.
Okay, okay.
That is the way.
Yeah, the watcher actually, this would be like system design of the watcher. So we can just think of the abstraction.
Yeah, maybe, yeah, you
Right,
can say that
yeah,
that is
yeah,
what it is, yeah.
Right.
So they anyway, this grokking has very high level. It mentions about all these blocks also. They don't go much details about that. Yeah.
Right, right. Because if Dropbox could do without Merkle tree, then why would Git use a Merkle tree?
But I have one doubt.
Mm-hmm.
Guys, I have one doubt. So if we know the offset in the file, which is like the location of the character, right? So and like we can divide the entire static file into blocks, right? Or into chunks based on the size of chunk. So each chunk will start from a particular offset and it will go till that size, right? So it's a static mapping. So if we know the offset, our work is done, right? We can get the chunk ID also from the or chunk number also from the offset.
But
only,
is this
right?
true for all file types? Like maybe for the text files and all?
Okay. For text file, okay.
Let's say I edit some image, I put some logo on top of it. I don't
Yeah,
think I can map it directly to an offset.
Yeah, because image files are so complex, they actually use different algorithms to render it. It's not so easy. Yeah, right. Go ahead.
Yeah, the files should be splittable, right? So linearly. Otherwise, yeah, if it's a compressed or a kind of encrypted file, then the algorithm may not work.
Right.
Because it's gonna change the entire hash and even the offsets.
Okay.
So encryption is interesting. If we are sending encrypted chunks, then the cloud storage and nobody except the client can actually view the files.
Not just encrypted, I think compressed, I guess, because otherwise the uploads would be late, I guess.
Right, compressed.
So in the worst case, you will end up uploading all the chunks, right? If that is the case.
Yeah, worst case it
can't do
will.
much there.
Yeah.
Right. Yeah. If it is updating the whole file, then surely it will have to update all the blocks, even if a single character is being updated. Yeah. So what it talks about here, the watcher, it says like it will monitor the local workspace for all those events, and watcher also listens to any changes happening on the other clients that are broadcasted by the synchronized service. And for indexer, he says like indexer will process events received by the watcher and update the internal DB, that is the metadata DB. And with this information about the chunks of the modified file, and once the chunks are successfully submitted or uploaded to a cloud storage, the indexer will communicate with the remote synchronized service to broadcast changes to the other clients and update the remote metadata base.
No, like I was reading the documentation from Dropbox, and it's like you said that when all the chunks are uploaded. So if you think about it, like when all the chunks are uploaded, so in that case, the other clients like they'll have to wait for a long time. Suppose you have a very big file. So what happens is they said that it doesn't happen in a single request. They have to make multiple requests due to the amount of data they need to upload. So when one request upload of one request gets completed, the synchronization to another clients gets started. So the synchronization to other clients is just one you can say commit behind the upload.
So once block server tells the client that everything's updated, so then
Not
index
everything,
server tells
not everything. Suppose you want to upload a file of 10 GBs, correct?
Right, right.
And that file is split up, say, in chunks of 1 GB each. So you have 10 chunks. Now, in a single request, assume you can send only 2 chunks, right?
Right.
So you will have to make 5 requests to this block server.
Right.
Right. So when first request gets completed, and second request starts to upload the third and the fourth chunk. So the first and the second chunk, whose upload has completed, they start getting synced to the other client application.
Okay. So we tell metadata for each chunk what is the version. Like
yes. right?
Okay.
So I mean, I just read this thing on this.
So that happens
Dropbox
parallel, you mean to
documentation.
say. It doesn't wait for the
Yes.
whole file to get uploaded.
Like
No,
a
it doesn't
pipeline
wait.
of process.
Yeah, that
Pipeline
makes
of a
sense.
process. But then, like, I had a doubt here. Suppose the file is corrupted at end, like, it gets to know that this upload shouldn't have happened and it cancels everything. So it's kind of an unnecessary processing it's doing at the other clients, isn't it?
Yeah,
Yeah,
but
it's
that will
again
happen,
automatic.
right? Yeah.
Right, but then he would roll back.
Yes, he rolls back. I mean, he wipes out the data from the clients and from its S3 storage. It wipes out everything.
So those sequence of events has to be followed for all clients, whether it
Right.
is, yeah, you can't help, right, in that case. But
I think the
given,
whole download has to be atomic, right? Like until
Yeah.
unless you download, it's like a temporary storage that you'll be using. So until unless you make sure that all the chunks are downloaded and it's validating the hashes of the each chunk, it's still a kind of a temporary storage. And then like you can just simply swap the folder.
Okay.
But then
Okay,
that
so we don't
temporary
replace it.
storage
Yeah.
needs to be for the chunk, not for the whole file, if you think about it.
yeah, but he's
Yeah.
saying that it's just in the local storage, like maybe the RAM, it's not going to be.
No, it can be on disk because it's GBs, right? We are talking about GBs here. So it can
Yeah.
still be in a temporary temporary folder, and you can simply swap once you're done.
Yeah, so
Yeah.
it's called two-way commit, right?
Yeah, something like that.
Okay.
Yeah.
Okay. Good to know that. Yeah. Thank you. Okay. So now they just talked about, how we can handle this file transfer efficiently. As we said, it can be divided into chunks and all that stuff. And why it is to be divided in chunks, because, and also the size of the chunks matters. If we use a smaller chunk, then you'll have to upload the file many times, means many chunks have to be uploaded. But if it is bigger one, then it will be a network bandwidth issue and all that stuff. So you have to choose a chunk size. Therefore, they have chosen 4 MB, and I'm not sure whether that is what is currently they are sticking to, but it all depends on, they might have changed also. And we also discussed about why you want to keep a metadata on the client, and that makes sense because if you want to do offline updates, we need it. And also it saves a lot of round trips to the remote server if we have a local metadatabase. And as you suggested about, right, how the clients will keep on syncing with the changes. One way is to actually keep polling the server, but that will be not a good way to do it, and it will not be scalable. So the other way would be to use HTTP long polling. And so whenever the server has some information, it can actually inform the client about it.
But then
Right.
HTTP long polling, even that has a timeout.
Right.
So they said that there are 3 ways in which the server can send. One is WebSockets. That doesn't make sense. I don't know why they don't make sense. I mean, I don't know much about WebSockets. Next, they said was this long polling, and they have a time to live. So that's why even that doesn't suit it. Because if the time to live is over, in that case, the client needs to again establish the connection. And the third way was server sent events. So for this pushing, they always use the server sent events. I mean, I'm not aware of how internally these 3 concepts work.
But why do we need real time communication here? Because
Yeah,
even when the client opens, it can pull it, right?
Yeah, when the client is switched off, so long polling would be better than SSE. If client is powered down, then SSE should not be sending, right? So long polling is only when client is alive and file system is alive.
Yeah, and WebSocket will be like too much because it's continuously engaging with the connection, right?
Okay.
Correct.
Yeah.
Correct.
So HTTP long polling fits in this scenario. So because
Shouldn't
it's
we
actually
use some async message queue?
yes, async message queue, like, because when the connection is on and if we have any information, that queue will be sending all the data, right? So they will surely have a messaging infrastructure between the clients and the synchronization server.
But I'm questioning, why do we even need long polling or pending connection?
So that only alive clients are getting the synchronized updates, the push.
And like we have a metadata changes, right? So we don't need a
So that is if the requirement is if the client is not running. Is that what you are addressing?
No,
Yes,
the
I think
requirement is
that's why
suppose we
long.
have 3 clients, correct? One is desktop, other is mobile and browser. Suppose
Yes.
you have an
This is a
account
way
and
of
right now you are
notification
editing a
mechanism.
file using your browser. So once that gets uploaded from the browser, your mobile and the desktop, even they should receive the update, correct?
Correct. But if your desktop is powered down, then unnecessary we don't want to waste bandwidth. So the mobile, if it's powered on, then every 5 minutes it's starting a long poll.
Yeah, and there won't be communication unless the
there,
server has any message
there,
to send it back.
I mean, as per the video, they says they maintain something called notification servers or notification service. So these clients keep connected to notification servers because the servers cannot connect to clients because there might be firewalls and other.
Okay.
So clients do the long polling, I guess, and whenever there is a change, right? The change is propagated in a hierarchical notification servers because if they want to propagate in a one server to notify all the notification servers would be not possible because of the kind of number of notification servers that would be there. So they made it in a hierarchical notification server because first level of servers will only tell to the next level of servers and next level of servers to the remaining level of servers, so that notifications can be propagated and then the clients can get the details, like there is some update and it can download and read the changes.
Sorry, I didn't
But
get
how
it.
is the
Why do they need
hierarchy?
this hierarchy? Yeah, where
Yeah.
is the hierarchy? Like, why do we need this hierarchy word?
Because usually we have only 2-3 clients. That is what I ask for what they say. Typically, the user will have only 2-3
No,
devices.
not per user, right? There are millions of users, right? And each one is having this connection to the notification server. And whenever there is a change, they have to propagate that change to all the servers because the top level servers doesn't know which client is actually connected to which notification server, I guess. So that propagation is needed because of that.
So you mean to say the sync server will be actually instances of many of them, right?
Yes.
So, yeah. So how do we identify those sync servers? So that notification server will actually will actually take care of it. Okay.
Yeah, and then it is not this arrow you have mentioned. It is from client.
Which one? The client sync server
I mean,
to client.
basically, the notification service, right? We are calling sync server as notification service. I mean, they are calling. So client is calling sync server, not the sync server is calling client. So your arrow you mentioned in reverse, right?
Okay, so you are saying it should
No, but
be
then
this
even
way.
sync server
Wait.
is telling the clients. I think it's
Yeah.
absolutely right.
Metadata server sees that hash has changed. It tells sync server hash has changed.
Yeah.
Sync server updates all other clients.
Right.
So you mean take the arrow for the long poll or like a heartbeat or something?
Yep.
Yeah, as per the MIT video, they are maintaining a hierarchical notification servers to notify the changes actually, and clients are connected to notification servers.
Okay.
No problem. Yeah. So
What is hierarchical notification server? I couldn't understand that part.
One server responsible for one set of client, then one parent server for
No.
3-4 sets of.
One sync server is responsible for the set of sync servers. So it will notify only to that set. And that set of servers will be having other set of servers which is responsible to notify there is something.
Okay, and finally one
DNS resolution.
To me. Balaji, can you explain a little bit more?
Let's say a sync server, there is 2 other sync servers down to that. Okay.
Okay. So you want to draw one more here. Okay.
Down to that, there will be for each of the sync server, there will be 2 other servers.
Okay.
Okay, you mean
So
to treat
when there is a change, yeah, it's a hierarchy.
Okay.
So when there is a change, when first server, when one person has to intimate to all these maybe 6 or 8 servers,
Are you talking
the
about
number of
Meraki tree
connections and
something?
threads might not be possible. So what they did is they did this hierarchical way so that each sync server will only tell the notification of, changed notification to the remaining 2 servers, and remaining 2 servers will propagate the change to the servers down to that.
And then
And at the most bottom, it will be a client, right?
Right. Yeah. So whatever.
Yeah, at the most bottom, it will be a client. Correct.
Okay, got it.
So they are reorganizing clients based on the sync servers and the notifications.
Basically, to reduce the load on accepting one sync server, all the notification changes or something like that, so that, or to notify to all the notification servers, it might not be possible by a single server.
Okay.
No, of course, you need multiple sync servers. There is no question about that. But I didn't understand what is the problem this hierarchy solving.
No, the hierarchy problem is basically to solve, to basically see if someone has to notify to 1 lakh notification servers at a time.
Yeah.
It has to do that 1 lakh times of sending the messages.
It's basically fanning out, right?
Fanning out, yeah.
If there is
fanning
one
out.
file shared across multiple users, and you want to notify everybody, then you would need to fan out basically.
So, and
right?
basically that has to be done by a single process or a system. So, but
why need this tree structure? We can run synchronous in parallel, right?
Sorry,
was this yes?
What I mean, why need tree type of structure, the synchronization server? We can
even
run
I didn't understand.
To decimate the load, I guess. Decimate the
I
load
guess
on
so.
one server to notify all of it.
No, but eventually you would be using some kind of a message queue here, right? So you will have a message queue.
Yeah,
and
there
you'll
has
have
to be a
multiple
message queue.
consumers.
Yes, I mean,
consuming.
I think
You can parallelize it.
Yeah, that is that. We'll have to do that.
There is a concept of Meraki tree, okay? Are you talking about that thing?
No. It is basically to decimate the changes to all the servers, that there is some change, so that clients could know that change.
Yeah.
So tell me one thing, only leaves are connected to clients, right? Parent will not connect to anything.
Yeah, only leaves are connected.
Okay. So it's just a smart way of routing basically. Like,
right.
Yeah, whenever
like how
there is a
geographically we
response,
route or something.
Yeah. So whenever there is a response for all the clients, actually that response will be done that way. You'll need some messaging queue system, and also you use the servers in a hierarchy.
Also, this way it can make it to log in kind of a thing. Suppose you want to send notification. So in this example, at the second layer, you have 2 servers, right? So maybe using geography or some other technique, like it decides that it needs to send the notification to only the left one, right?
Or the cross regions, yeah. Okay.
Yes, so it
each
has
server
almost
can
half
filter
the load kind of a thing.
Correct. Each server can like filter it, like this is not in my children, I'm not taking it.
Yeah, selective. Okay.
So the
And at the
parent
bottom
is like
part,
a
yes,
sub.
it creates dedicated queues for all the clients.
This root sync server will be segregated based on that file or user ID. How it will segregate?
Might
It's
be
like a
some
subscription. It's like a subscription actually.
It
So
has to be
generally subscribe at the user level or the account level, and depending upon this one such architecture, even people use Kafka or something like that as well to send them notifications. But here, if you are taking like a tree, generally the leaf ones are actually subscribed to a particular account or the events, so that if any change comes for that object or something, those particular servers are notified. Let's say if the user has 2 devices and both are connected to 2 different machines, and one his particular file has changed, so all the servers with the devices connected for that particular account will be notified.
I think
okay, so you bubble up like all of these are affecting this user, you bubble up like how we do in some access control kind of things.
I think in my thinking, right, it boils down to the connection, because you need to find a box at the end leaf which has connection to a client. Otherwise,
Right.
if you're diverging the messages to two different nodes, right? So you need to find a box which has the connection, right? So that's what I think the other one was
It's a
saying about the
circuit switching
subscription.
network of
The
telephone.
subscription
Like,
translates to a connection. Yeah.
Circuit
Right,
switch
right.
of telephone is each digit is one of the 9 children.
Exactly.
Then again 9 children,
So,
9 children. And
does
manually
it
people
mean
would
that,
actually.
Yeah. Got
Yeah.
it. So I think, does it mean that we need to also have kind of a
But what
map
I
which
think
maintains
is the sync server
maintains
is listening to some event changes from the queue only, but from there to notify to all the sync servers which are actually listening to that event would be done in a hierarchical way.
Okay, no problem. So maybe, on this Monday, we'll actually again get back to that, I think, because it's almost an hour, and I'll also read about that MIT lecture, right? Okay. And let's get the exact details what it is. I think that's interesting also.
Can we share the link of that MIT lecture?
Sure, I'll share on that Discord channel.
Sure.
Okay. Okay, then I think because we discussed earlier, we'll keep it only 1 hour.
That's not a MIT, that's a Stanford lecture.
Oh, sorry, Stanford, yeah.